have seen that the reactivity of all metals is not the same. However, the reagents oxygen, water and acids are not useful to determine the relative reactivities of all the metals, as all the metals do not react with them. So, today we shall learn about the reactivity series. My name is Shubhajit, and today with me is Hemalata, and this time we both are going to start a new topic, the reactivity series of metal. Before entering the next topic, let's revise the previous one. Mercury and gallium exist in a liquid state at room temperature. Non-metal bromine, which exists in a liquid state. Ductility is a property by which metal can be drawn into thin wire, and metal is called malleable when it is beaten into a thin sheet. Graphite, an allotrope of carbon, is an exception as it is a good conductor of electricity. Sodium and potassium metal react rapidly and vigorously with water and liberate hydrogen gas. Aqua regia is prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. Learning outcomes. Reactivity series of metal. Chemical properties of non-metal. Ionic compound. Keywords are non-metallic oxide, reactivity series of metal, ionic compound, force of attraction, cations, anions. This is the concept map for today's lesson. We have seen that the reactivity of all metals is not the same. However, the reagents oxygen, water and acids are not useful to determine the relative reactivities of all the metals, as all the metals do not react with them. The displacement reaction of metals with solutions of salts of other metals serves this purpose. If metal A displaces another metal B from the solution of its salt, then it means that metal A is more reactive than metal B. Point number 1. Take a clean copper wire and a clean iron nail. Point number 2. Dip the copper wire in ferrous sulfate solution and the iron nail in copper sulfate solution. Point number 3. Keep on observing continually at a fixed interval of time. In the previous activity, iron has displaced copper from copper sulfate. This means that metallic iron is more reactive than metallic copper. Scientists have developed the reactivity series by many experiments on displacement reactions. The arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Metals are divided into the following groups according to their reactivity. Point number 1, highly reactive metals. Point number 2, moderately reactive metals. Point number 3, less reactive metals. Non-metals are a collection of elements having less similarity in physical and chemical properties. Non-metals are also called electronegative elements as they form negatively charged ions by accepting electrons. Some examples of chemical reactions of non-metals are as follows. Generally, non-metals combine with oxygen to form acidic oxide. In some cases, neutral oxides are formed. Generally, non-metals do not react with water except the halogens. For example, chlorine on dissolving in water gives the following reaction. Generally, non-metals do not react with dilute acids. Halogens are exception to this. For example, chlorine reacts with dilute hydrobromic acid in the following reaction. Non-metals react with hydrogen under certain conditions such as proper temperature, pressure, use of catalyst, etc. The compounds formed from two units, namely cation and anion, are called ionic compounds. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. You know that this force of attraction between cation and anion is called as the ionic bond. The number of cations and anions in a compound and the magnitude of the electric charge on them is such that the positive and negative charges balance each other. As a result, an ionic compound is electrically neutral. Ionic compounds are crystalline. The surfaces of all the particles of a crystalline substance have a definite shape and are smooth and shiny. The regular arrangement of ions in the solid ionic compounds is responsible for their crystalline nature. The arrangement of ions is different in different ionic compounds and therefore the shapes of their crystals are different. The main factor that determines the general arrangement of ions in a crystal is the attractive force between oppositely charged ions and the repulsive force between similarly charged ions. Because of this, the general crystalline structure has negative ions arranged around a positive ion and positive ion arranged around a negative ion. Two of the important factors responsible for a certain crystal structure are as follows. Number 1. Size of the positively and negatively charged ions. Point number 2. Magnitude of the electrical charge on the ions. The electrostatic attraction in the neighboring ions with opposite charges is very strong. That is why the melting point of ionic compounds are high. Also, the ionic compounds are hard and brittle. The attractive force between the positively and negatively charged ions is strong. Therefore, the ionic compounds exist in a solid state and are hard. The intermolecular force of attraction is high in ionic compounds and large energy is required to overcome it. Therefore, the melting and boiling points of ionic compounds are high. Ionic compounds are water soluble. This is because The water molecules orient in a particular manner around the ions separated by the dissociation process. As a result of this, a new force of attraction is established between the ion and the surrounding water molecules, replacing the original intermolecular attraction. And aqueous solutions of ionic compounds are formed. Ionic compounds are, however, insoluble in solvents like kerosene and petrol. This is because, unlike water, a new attractive force cannot be established in these solvents. The ionic compounds cannot conduct electricity when in solid state. In this state, the ions cannot leave their places. However, in the fused or molten state, they can conduct electricity, as in this state, the ions are mobile. The aqueous solutions of ionic compounds conduct electricity as they contain the dissociated ions. On passing current through the solution, the ions move to the oppositely charged electrodes due to the electrical conductivity is fused and dissolved state. The ionic compounds are called electrolytes. What have we learned today? The arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Non-metals are also called electronegative elements as they form negatively charged ions by accepting an electron. Non-metallic oxides are acidic. Non-metals generally do not react with water and dilute acid. Ionic compounds are made up by donating and accepting electrons. The ionic compounds are hard. The ionic compounds cannot conduct electricity when in solid state. In the fused or molten state, they can conduct electricity. Thank you for watching this video. Please go through the home assignment and answer the question.